All right. Good morning, everyone. How is everyone going on this beautiful Wednesday morning? Coming in here without some maths, which is nice. Welcome to the Wednesday lecture. Just wanted to also remind you there's no lecture on Monday, which is devastating because we're going to do some really, really fun things today. And we're going to go over a few of the things from last week and from the Kahoot and stuff. So we're going to have a big 2 hours. So I hope you've got snacks because you will need them for the energy. And also apologies in advance. I have stupidly worn a green dress, so I might disappear at some stages of the lecture behind the green screen. I'll try not to blur into it. All right. Let's do it. Okay. I'm so excited. I don't know what to do first. Yeah, I'm sorry about the slides. I was so excited. I got them there at lunchtime yesterday, but I forgot to actually give access. They are available now. I forgot to change the file permissions, that's the second time I've done that. So I will, I was really proud I did it on the Monday slides, and then I didn't do it on the Wednesday slides. So I'm sorry about that. I will make sure that I do it on all of the slides from now on. Well, aspirations, but I hope I do. But please tag me in the forum if I don't do it, and then I will, change the access. Okay, let's do it. Okay, so on Tuesday, I'm not very good with days. On Monday, I have no idea what the day is. I've just realized it's Wednesday. Those 2 public holidays, they completely threw my timing off. I felt like it was Saturday on the Thursday, and then on the Saturday, I couldn't understand why it wasn't the Monday. So apologies. So we talked a bit about style and we talked about functions. But before that, we also did a Kahoot where everyone wanted to know the answers and we didn't do the answers. So let's go through the Kahoot as our revision, and then we're going to do a little function as a recap, and then, drum roll please. Yay, arrays! I love arrays. Okay, let's go through this Kahoot. So the first one was, how many times will this loop run? Okay, and there were a few answers, and people got it wrong. So I guess I was trying to trick you a little bit, but still. Let's have a look how many times it will run. Okay, I've got int count is equal to 1. So let's say count is equal to 1. I'm going to go in here and check if count is less than 4. Yes, it is. I'm going to print out. So I'll do the prints here. So I've printed out 1, new line, and I've increased the count. So count is now 2. I'll go back here and check. 2 is less than 4. Yes, it is. I'm going to go in there. I'm going to print out the 2, and then I'm going to increase the count by 1. I'm going to check again. Is 3 less than 4? Yes, it is. I'm going to go in there and I'm going to print it out, which is fantastic. And I'm going to increase the count to 4. And then I'm going to go in here and I'm going to say, is 4 less than 4? No, it's not. So I'm going to exit out of this while loop. So how many times did that loop run? That loop ran 3 times. Okay, that's the first question. I'm still on a pen, which is why nothing is happening. Okay, let's go to the second. What is the last output of this code snippet? Let's have a look. What's the last output of this code snippet? Okay. Well, I just did it, didn't I? So what's the last output? It was the same one, wasn't it? And I just erased it. My goodness. So does anyone remember what was the last thing before I so nicely erased it for everyone? Was it a 4, the last thing that I printed out? Or what was the last output? Yep. So the last output was, the last thing I printed out was 3. I never got to 4 because when I got to here, count was equal to 4, but this wasn't true, so I didn't output anything. I just kept going. So my output was 1, 2, 3, and that was the last thing that I outputted out. Okay, let's have a look at the next one. What will the final output look like? Okay, now this one, people did not love this one. So let's do this one, and this is the while loop inside the while loop, which will be useful for us for next week when we do our arrays. Okay, so we've got, I'll go this way, otherwise it's like a really weirdly positioned camera. Okay, I and j. Okay, I is equal to 0, j is equal to 0. And I'm going to go in here. Whilst I is less than 4. Yes, it is. Good. It is less than 4. While j is less than 4. Yes, it is. So I'm going to go inside here and I'm going to print out the j. The j is 0. So I'm going to print out 0 and a space. So that's a space. And then I'm going to increase the j. So j now becomes 1. And that means I'll go back to the top of this while loop. And I'm going to check if that 1 is less than 4. Okay, great. 1 is less than 4. Yes, it's still true. So I'm going to go in here. I'm going to print out 1 and I'm going to print out a space. And I'm going to increase the j again. I'm going to go back to this while loop, check the condition again. Is 2 less than 4? Yes, it is. I'm going to print out a 2 and a space. I'm going to increase the j to 1 more. Fantastic. Still going strong. So now it's 3. Is 3 less than 4? Yes, it is. I'm going to print out the 3 and then I'm going to increase it by 1 and I'm going to check again. Is 4 less than 4? No, it's not. So I'm going to exit out of this while loop and I'm going to keep going. Okay, I'm going to print out a new line. Excellent. So I'm going to print a new line here and then I'm going to increase the I. I don't know why I crossed that. I didn't want to cross it. I got overexcited. Okay, I'm going to increase the I. Excellent. Back into the while loop. Is 1 less than 4? Yes, it is. I'm going to go in here and check. 4 is less than 4. So it's, I'm not going to go into this loop because it's not, I haven't reset it really. So I'm going to print another new line and then I'm going to increase the I again. So the I is now going to be 2. I'm going to go back and check. Is 2 less than 4? Yes, it is. Going to go back in here. J is still 4. So 4 is less than 4. That's not true. I'm going to skip this while loop, print another new line and increase the I to a 3. And then I'm going to go back to here again and I'm going to check. Is 3 less than 4? Yes, it is. Going to go in here. J is still 4. 4 is not less than 4. So I'm going to skip this while loop and print out another new line. This is not a 1, by the way. This is, I can't remember how does a new line. This is a new line. I'm going to increase the I to 4. And finally, I'm going to check here. Is 4 less than 4? No, it's not. So I'm going to exit out of this while loop. So what it's going to print out for me is 0, 1, 2, 3, and then new line, new line, new line, right? Because of that new line. So that's why it's going to be what it is. It's going to be looking like that. Okay, I hope that made sense. But you see, sometimes if it doesn't make sense, what you need to do is you just need to grab a pen and paper and go old school. You just need to write out exactly, you are the computer. Go through it line by line and print out what it's giving you because it will help you to understand. Yeah, the last output should have been 3. Yes, yes, yes. Sorry, it shouldn't have had a 4. I got overexcited when I wrote it the second time. Yeah, absolutely. So it should have been 0, 1, 2, 3, like this. 0, stupid pen. 0, 1, 2, 3, and then it will have the new lines down there as well. Okay. I'm still in pen mode. Let's go to this one. Which one correctly assigns something to the spice member of the following struct? Okay, to assign something to a member of a struct, we use the dot parameter. So if my variable name of this struct food, the variable name is dish, then I refer to my variable name that I want to assign to, which is dish. Then to assign into the spice member of dish, because remember when that struct is created, when this variable line 8 runs, it creates something called, variable called dish of type struct food. And it's got 3 things in it. It's got an int for a spice. it's got an int for a flavor, and it's got a char for a name. So if I want to enter inside the spice and assign it to spice, I use a dot to do that, and then I refer to whatever field I want to assign to. So dish.spice is the one that will assign me in. Okay, so that was that answer. And in here, what values will Cooley and Alsatian make? Okay, so remember that in enums, it starts enumerating at 0. Okay, it starts enumerating at 0, but then it takes one more from the previous number, whatever the previous one is. So if it starts assigning at 0, then this over here is equal to 0, this is equal to 1. This is equal to 5 over here, which means that this is 6, this is 7, this is 8, this is 10, and that means that this is 11. So Cooley is 0 and Alsatian is 7. Okay, and last but not least, this is a legal way to define enums for one single program. This is not a legal way to define it, and the reason for that is because both of these enums have the same thing in them, okay? You can't have the same states because it's out of scope rules. So you can't have, they can have the same value, like you can have Cooley is equal to 0 and Kelpie is equal to 0, that's legal, but you can't have the same state names in two different enums. So this is not a legal definition. Okay, fantastic. How's everyone feeling? How's everyone feeling for that? Tom, can you run a quick poll, please, just if everyone's happy with that? And whoosh, this screen disappears until it reappears again for our Kahoot later today. Okay, and so, you know, I was just saying to Tom, I've got a lot packed into this lecture. It's good to be aspirational. If we don't get through it all, don't worry about it. We'll just pick up where we left off, okay? I'm not going to push past when it's when everyone's struggling. It's okay. You don't need these things in assignment 0. And you will need what we learn on Wednesday next week will be useful for assignment 1, and assignment 1 will be released next week. Okay. So today we're going to look at functions and we're going to start looking at arrays. The lecture code for today, and you wouldn't believe it, I remembered to chmod this one. This one actually has access to it. Tom will paste in a second. He's just doing the poll. I've got him typing too many things. And someone's asked, will we lose marks for stuff? We don't use functions for assignment 0. No, you will not lose marks in assignment 0. Don't worry. You don't have to use functions if you don't want to in assignment 0. That will change in assignment 1 though. Okay, quick recap of functions. Function is a block of statements that performs a specific tasks. What does it do? It improves our readability of the code. It improves reusability of the code because you can use a little function elsewhere. You know, if you've got a function already that you've written for doing, you know, I don't know, adding two numbers together, you can reuse it in other chunks of code that might do that. It makes debugging easier because you can sort of switch off functions, like you can, you know, comment out a function and see if it's the one causing problems. So it's much easier to debug your code. And it reduces the size of your code because you can, you know, reuse the functions as needed and wherever they're needed as well. Okay, so let's have a look. I've just recapped everything that we've done so far. So let's have a look at a little piece of code to do a little recap, because I think always better to see it in action and then you can, you know, then you know what's going on. Okay. Let's have a look. So this program recaps what we've learned about functions. Write a program to calculate the area of a rectangle. Just take you to high school maths all the time. And my unhelpful comment, how can we solve this problem? Okay, what do we reckon? How can we solve this problem? Let's do some steps to solve this problem. Let's do some steps. So what do you reckon the first step will be to solve this problem? Oh, printing of the pyramid. The pyramid is a fun one. We are going to run out of time though. Maybe I'll just record a video of myself printing the pyramid. Fun bonus. Yeah. How are we going to solve this problem? Who can help me write a simple program that calculates the area of a rectangle? What are some steps I should take? Yep, take input and length of width. Yep, okay, good. So maybe ask the user for length and width of rectangle. And we're going to use a printf statement to ask them. And then we're going to input the length and width. And we're going to use a scanf to read those. Excellent. Formula for the area. Excellent. Okay. So then we want to do the area, calculate the area by area is equal to B times W. I can't remember. Length times breadth. It should be L times whatever. You know what the formula is. Good. Someone's even giving me what the function should be. I love it. Okay, calculate the area and then output the result, which will be a printf statement. There's no ifs or buts or anything about it. Okay, let's do it. Let's write it quickly. So let's have a look how we can do it without... Okay, so I'm going to need a length, a width. Those are not the same thing, are they? No, I'm okay. Length and width. Okay, so I'm going to have an int length. I'm going to have an int width. And I'm going to have an int area. Okay, I've got my three things. Then I need to ask the user. So I've got my first step is ask the user the length and the width. And I've said I'm going to use a printf here. Okay, so I'm going to printf. Can you please enter the length of the rectangle? Should we do it as two separate things or together? Doesn't matter. I didn't specify it, so I'll do it as two separate things. Okay, then I'm going to scan it in. So it's going to be a %d. And it's going to go ampersand into length. And then I'm going to do the same thing for the other one. Okay, so length, let's do width. Mind you, no error checking still taking place, so that's something that we can think about here as well. So I'm not going to do it right now, but think about error checking here. What can go wrong? Who can tell me what can go wrong here? Okay, so now I've got a length and a width. Now I want to calculate the area. So let's say I'm going to call the function area and I'm going to give it the length and the width. And that really gives me what my function is going to be. And I'm going to place the result into area. Yeah, negative length. Yeah, beautiful. Oh my gosh, great error checking. So things that can go wrong. Input of negative numbers. Fantastic. Input of chars. So check what scanf returns. And this is something that you can play with as well to make sure that you can float values. Okay, interesting. Input of floats. Input of... It will cut you off because it's expecting a D, so it'll just read up to the decimal point and then it will stop reading. But it is a good one to check. Input 0. Yeah, it can't really be 0, can it? You can't have a length of 0. That doesn't make sense. That's a good one. Well done. So you really want your length and your width to be greater than 0 as a condition. And you want your scanf return also to have inputted. Well done. Some really good, excellent. Well done. Okay, great. Then I'm going to have a function that will calculate the area, and then I'm going to print it out. So I'm going to print out the area is %d. New line, and we're going to give it an area. Okay, so now let's write this function. Okay, so function to calculate area. And I can see here the output is going to be an int because that's what I needed to give back to me. And what am I giving it? The inputs, I'm giving it int length and int width. And the name of the function, I have said that it's going to be calc area. Yeah, absolutely. Lengths can be floats, absolutely, and you can make them double. So it is definitely up to you. We can absolutely make this a double. Why not? Both of them can be a double. Up to you, okay? And you can really change it. Right now, we need to consider input of floats because we've said they're ints, but they should probably be floats because you can have decimals. Okay. So function, the way it's done, first off, we write whatever the output is going to be. What's the data type? It's going to be an int. Then the name of the function, so calc area, and then saying what it is that I'm giving it. I'm giving it an int length and an int width. And that means I've got really my whole definition. Now here we have done so far int area is equal to length times breadth. And then I'll say return area. Now here is a shortcut for you. I can actually return the calculation itself. So instead of doing int area is equal to that return area, what I can do instead is I can say return length times width, because the result of that is actually an int, so it's fine. So I can actually do that and save myself a bit of space and a bit of, make it look neater. Now someone is saying, yes, we absolutely have to. So then remember, because C reads things line by line, it's not going to know that this function exists down the bottom, which is why we have prototypes where you copy the definition of this function and stick it above your main to let C know that this function exists and it's coming. So all it is just the top line of your function with a semicolon after it, and that's the prototype. Okay, should we see if it runs now? Let's have a look. So DCC, I forgot what it's called, functions recap, functions recap. .co function. Yay! I love it when it compiles first go. Let's do 5, let's do 6, area is 30. Yay, it works, okay? So let's talk about these. This is an excellent question that's asked. Is the variable declared in the function only recognized within the function? Yes. When I declare this variable here, int area, this variable only lives between the curly brackets, and I'm going to talk about that in a second as well. So this area is different to this area. This variable lives between this curly bracket and this curly bracket. So when it returns whatever it returns and it gets to this curly bracket, this variable is killed in memory. And it doesn't recognize that these two they're not the same thing. They're two different things. I have called them the same thing to demonstrate this, but they're not the same. They are two separate things. And even when I send it a length and a width, it's not the same length and width here. These are copies of whatever these are, okay? They're not the same thing. All it's looking for is that I'm giving it 2 ints. I can call them number 1 and number 2, and it will have exactly the same result. So I can, except that, it's bad variable names, but I can actually call them. In here, I can say that I'm just giving it 2 numbers. I can say number 1 and number 2. And all it will do is it will just copy the value of the length, the first number into number 1, and the second one into number 2. And that means here it would have to be number 1 and number 2 because it doesn't know what length and width are. They're 2 different variables. So anytime it calls a function, it makes a copy of those things. Okay, so to use the output of the function, we have to declare a variable. Oh, thank you, Tom. Yeah. Okay, so how's that? Okay. Tom, if you can please run a thing for me. Thank you so much. Read my mind what I mean by thing, thingamabob, thingamajig. Okay, good functions. Okay, good. Okay, very good. Well done. And we'll keep using functions throughout, so hopefully you'll get more and more comfortable with them as we keep going. Okay, let's talk a little bit about memory, which I kind of started doing when I was talking about what lives and what dies in the brackets, in the curly brackets. So the C file that we have, okay, actually I'm just going to answer this question by Juno in the chat. Why don't we write the calculating function above the main function so that we don't need to write a prototype? You are right, you can do that, but yes, my program has about 15 lines in it, maybe 30, I don't know how many lines it has, 40 lines. And the function is 3 lines. So I can see exactly where the main is. I can see that this function is short, whatever else. Imagine if you have 1,000 lines of code, if you have 50 functions, 60 functions, it becomes really hard to read. And also, if one of those functions calls another function that might be sitting below, it will not be able to find it. So the order is now going to start making a difference how you actually write those functions above the main, in which order you put them in. So it's going to start becoming very unreadable and very, very, very difficult to keep track of what's going on, which is why we write the function prototypes. And later on in the course, we're going to learn about multi-file projects a little bit, because then you can see that they don't really just sit above your main. They go somewhere else so that you're not as confused by them. But for now, we pop them above our main, and that's the prototypes to make it more readable, to make it a lot more readable for the person, and to also counter that issue where the order of the functions themselves might make a difference to how we call things. Okay. No worries. And the next is a good practice to name the variables inside the function differently to the variables you'll be inputting. It's a really good question. Not necessarily. You can call them the same thing if you want, and that makes it easier to read often, because definitely, you know, what I had before is much easier to read than this. Number 1, number 2 doesn't really make any sense. It was much easier to read with length and width. It's just knowing that they're not the same length and width. If I change length and width after this function, that's not what's going to go to there. Okay. So the way memory works, okay, our C file is stored on the hard drive. Excellent. The compiler compiles the code into another file that the computer can read. So remember, the code that we're writing in VS Code, that's for humans. It's so that we can read it and we can understand it, and so that we can write it, because it's not very easy to write in ones and zeros. The compiler translates our C code into something that the computer can read. And we don't need to care about what that executable file has inside it, because it's not for us, it's for the computer. So when we execute code, the CPU will process the instructions and perform the basic arithmetic stuff, but the RAM will keep track of all the variables that you have, of all the constants that you have, of anything that you declare basically, and of all your functions. Your functions, when they're called, they will go into your RAM memory processing. So the CPU just takes care of the instructions inside and arithmetic, but then your variables that arithmetic is done with, or those instructions are done with, is actually on your stack or your heap, or maybe global. There's a lot more to it, right? So reading and writing to variables will change the numbers in the RAM. And I've mentioned this before, and I'm just going to keep mentioning it a few times just so that before we actually do it properly, so that you have a little bit of this pre-understanding of what's going on. You don't have to understand this in detail yet, don't worry, but it will explain a lot of things in a few weeks when we do go through it in a bit more detail. So memory is divided into really the stack and the heap. And that's, I mean, there's more to it, but the stack and the heap is where we store our variables. The stack is an ordered stack, okay? Think about it, you know, when you stack a bunch of plates on top of each other, it's ordered. You can't just remove a middle plate without causing some sort of absolute crash, you know, of many plates crashing on the floor. That means that, you know, you keep stacking things on top of each other. So anytime a variable is made, it goes on top, new variable on top, new variable on top. So it's ordered, right? You're stacking things on. And then a heap, exactly what it sounds like. It's just a random mess, right? Insert something wherever you can find space for it. Now, the implications that it has for us is that we use them for two different types of things. So stack is where we keep which functions are called and what variables are created at compile time. And once we get out of those curly brackets, it's all removed from the stack. So once we finish running our program, all of that stuff is killed, right? All of our variables are killed. They don't just live on and on, because otherwise you'd run out of memory. That means that stack memory is allocated at compile time. So when you start running your program at compile time, these things are going to start sitting on the stack. So as soon as I declare this, length is going to go on the stack, width is going to go on the stack, area is going to go on the stack. I call a function, that's going to go on the stack. And so it's just going to keep stacking up, and then it's just all going to disappear after my program's finished. So that means that the stack is controlled by the program. It's not controlled by you. You have absolutely no control over the stack, really, because you can't make things happen there at runtime. This is different to the heap, which you are in control of. And this is the beauty of C. It allows you to get a very close look at memory, because, and we will do this in a few weeks, don't worry, but the heap can be changed at runtime, which means that you are now going to have a lot of powers. But with great strength comes great responsibility. So this is where C becomes, you know, quite a quirky, well, not a quirky language, but that's where the security vulnerabilities come into it. And it's with great strength, isn't it? I said that wrong. Whatever, I've changed the saying. So don't worry about it. You still don't have to understand it, okay? But think of your own memory, what it allows you to do. Computer memory is also important to consider when you're writing your code. We don't care about wasting in 1511, but you will start caring as you move on from 1511. The more you waste your memory, the slower your computer gets. I think everyone knows that. Everyone's run Windows where the program, or Microsoft. No, I'm not going to do that. No. But everyone, you know, well, if you've seen my computer, I've run every program on the planet. And actually, you know what? You've run VLab and you've seen it slow right down. So the more memory you waste, the slower your computer gets. It might lead to things crashing as well. You know, it just keeps building up. In this course, we don't really care, waste away. Our programs are too little to really make a difference unless you create a whole bunch of loops that just keep going and wasting space, or unless in later part of the course you completely plague your heap, which you might do. You can. Maybe we will do it as an exercise just for funsies. But you know, we don't mind because you're still learning. So don't worry so much about it. So we're going to learn about two things in this course. We're going to learn about arrays right now, and then we're going to learn about linked lists after the Flex week, which is so exciting. And they're two different structures. One's all about the stack, the other one's all about the heap, really. There are other data structures that you will learn about in further computing courses, but those are the two that we will cover in 1511. And choosing what you house your data in, or your data structure, really depends on what the problem is. Often you can solve a problem with both types of data structures. You can solve it with arrays and linked lists, and just one way will be wasting a lot of memory and one way will be a lot less efficient than the other, and a lot more complex to do, really. So some structures do lend themselves better to certain types of problems. So, without further ado, the array. Okay, who has heard about arrays? Arrays, 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 arrays. Who has heard about arrays? Oh, this is nice. I like how everyone's feeling. Okay, has anyone heard about arrays? Has anyone done, you might have done other code, or you might not have, and that's why you're about to learn a bit about arrays. It is a pretty important data type. Oh no! What a start! You hate arrays. Just wait. I'm going to turn you around. You're going to love arrays after this. You're going to love them. They're so amazing. Basically, an array is a collection of variables that are all of the same type. Okay? And think how this is different to a struct. In a struct, we can have an int, a double, a char, whatever we want. In an array, we have to have everything the same. So that means that we are able to access any variable in the collection easily, wherever we want. And we can change any variable in this collection easily. And those are the beauty of arrays. There are definitely some negatives as well, which we will talk about it. Okay, let's say, back to ice cream. Let's say I want to record the daily ice cream consumption for a week, okay? That is me recording an int every single day for a week. It's the same data type, but they're all kind of related. Oh my God, it's blurring me. It hates me. It hates my green dress. I'm sorry, computer screen. What about daily temperatures for a year? You're not going to have 365 variables, separate variables that you're going to store one item each in. No, you're going to have an array of these variables because you know that they are related to each other. Amount of time daily that I spend walking my dogs. Again, I'm not going to have, 50, 60 variables. I'm just going to have one variable. It's an array. It's an array of double, and then it might have all the times. What are some other examples? Who can think of some other examples where I could use an array to store the information into? What do we reckon? Can we think of some other examples? Tom, can you think of an example whilst there's a lull and a lag? Types of car, yes, absolutely. Maybe you have a car shop, not a car shop, a car. What's the place called where you buy cars? I forgot what the place is called where you buy cars. A dealership. Thank you, Tom. Oh my God. Let's say you have a dealership, thank you, and then you have all the different cars inside the array for dealership. Expenses per month, yeah, that's all the same type. A set of cars, yeah. Oh, a vector. Oh, that could get messy. Yeah. Zodiac animals. You could have an array of zodiac animals, absolutely. These are really quite, yeah, those are really good examples. I like it. Okay, this is what a restaurant menu. Yeah, you could. A restaurant menu would actually be an array of structs because each item on the menu has a name and it has a price. And it might have some other properties associated with it. So you might have an array of structs, which is really nice. Yeah, that's really nice. So you can have an array of anything. You can have an array of int. You can have an array of char, which is actually a string. You can have an array of doubles. You can have an array of, I've already said structs, haven't I? structs. You can have an array. You can have an array of arrays, which is coming next week. So you can have an array of anything. So if we group our data type as a collection, items, Super Rugby teams, absolutely. And again, Super Rugby teams lends itself well to having an array of structs because they will have things associated with them. Hotel rooms, absolutely. Again, really good lending to an array of structs. In an array of structs, do the elements of the struct have to be of the same type then? Yeah, so it will have to be like the same struct in each of the array boxes. So I envision an array, and this is really how I'm envisioning it, as basically a set of boxes. But it's all one whole, right? So it lives as a whole. Each box is exactly the same size because you're storing in it the same type of data, okay? Which means that everything is the same type. So we can access them as a group and we can loop through them and access each individual element as a collection. So for example, if I have an array of 7 things, please notice that arrays start counting at 0. Okay, always arrays start counting at 0, which always trips everyone up. And this is where one-off errors happen because you check beyond the boundary of the array. Because you might think, well, it's got 7 elements. I'll check what's inside the 7th index, but there is no 7th index. So index 0 accesses the first thing in the array, index 1, the second, index 2, the third, and so on and so forth. So basically, you can access any of these by referring to the index. What that means is, and what that looks like, let's say I'm tracking my ice cream consumption for a week. I'm not going to write the code because I've got it here. I'm not going to waste the time. Let's say I'm doing it without arrays, okay? And this is why I want arrays, because clearly I have issues and I need a lot. Look at Friday, I've gone wild, 7 ice creams. Okay, so let's say I'm doing it without an array. I don't know what an array is. I'm going to have a variable for each day of the week. Int Monday is equal to 2, int Tuesday is equal to 3, int Wednesday is equal to 3, int Thursday is equal to 5, blah, blah, blah. And then I want to say, great, if any day with 3 or more scoops, then I've had too much ice cream. So then I'll have to start checking each single variable that I have. So if Monday is greater than or equal to 3, too much. If Tuesday is greater than or equal to 3, too much. If Wednesday is greater than or equal to 3. So it's not very efficient. And this is really just, for a week. So, it's still doable, but it's not particularly efficient. You're repeating a lot of code. Definitely like this is a repeat all the time. There's 7 variables. That's hard to keep track of. And it doesn't really make much sense what's going on here. What if I'm tracking over a month? What if I'm tracking over a year? Will I need to use 30 variables? Will I need to use 365 variables? I definitely don't want to be using that many variables. So this is where I have an array. Okay, so to declare an array, I let the computer know what type of data will be stored in the array. So in this case, my ice cream consumption consists of ints because I'm doing ints. So it's going to be int. So that means that what I'm creating, if I do this, I declare this array, int ice cream consum 7. What it creates is it creates an array of 7 items. This is the number of things in the array. So 1, 2, 3, 4, 5, 6, 7. Each one of those things is an int. So that means that this is an int, this is an int, this is an int. They're all exactly the same size. So what it's created is it's created something that has 4 bytes for each int. There's 7 elements, so 28 altogether. Not that it matters, right? We don't care how much we waste in this course. Waste away. This array is called ice cream consum. Could I have found a worse name? I don't think so. So this is my array. It's got 7 things in it. And remember, the indexes are 0, 1, 2, 3, 4, 5, 6. Okay? This is just an array that's been declared. This array is empty. Now, once you've declared an array, you can't initialize it in this way. So I can't then say ice cream can sum is equal to this. I can do it all in one go. So I can declare it like this. After this, if I want to assign anything to it, I have to do it one thing by one thing. Like I have to do it element by element. If I want to give it values straight up, which is, not that, you wouldn't do that often, you would declare the array and straight away open a curly bracket and start placing things into it. And it will place them in order. So 3, 2, 1, that will go 3, 2, 1, blah, 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 blah. Okay. Oh, someone's asked such a great question. Can you use a variable for a number? Oh my gosh, reading. Not a strong point today. Can you use a variable for a number of items in the array? What a great question, okay? Really good question. Okay, and there's kind of like two answers to it. We're going to look at it a bit more after Flex Week, how to do a dynamic array. And even then it's dynamic to a degree, but it's not super dynamic. So the thing with arrays is that you have to let the compiler know how much space to allocate for it at compile time. And the reason for that is when you go to a piece of memory, okay, and when you've seen me draw the array, I draw it as one box with 7 items in it, or whatever else, however many items. What this means is that each item sits right next to each other in memory. And that means that we can ask for a different items by using the index, because as long as we know where the first place is, we really know where everything is, because everything is, if this is, each one is going to be plus 4 bytes, plus 4 bytes, plus 4 bytes. So you know where the whole thing resides, which is why we tell it at compile time how many elements we need, because it needs to reserve that much space for our array at compile time, because every single element of an array has to be sitting right next to each other. So there is something that we can do to make it more dynamic, and we're going to look at it after Flex Week. But usually if we need to use memory in a more dynamic way, we will use a linked list instead of an array. And that's something that we will learn after the Flex Week as well. So it's all really to do with how things are allocated in memory. And because we need an array to sit close together, well, we need everything to be together one after each other. That means we need to allocate that memory at compile time. Okay, I hope that answers it. I think I'm trying not to go on too many tangents. I get very excited about this stuff, a little bit too excited. Okay. Excellent. Okay, so let's say we have an array that we've declared and initialized. This is what it will look like visually. So it'll just apply these numbers into each box here. The indexing is going to start at 0, and then you can access anything you want in the array. For example, if I want this third element, that means I want ice cream can sum at index 2, because the index of where it's sitting is 2, and that will give me what's sitting inside that particular array index rather. If you try to access an index that doesn't exist, and this is a very common error, particularly accessing an index 7 in this case, a very common error, you will get an error, right? It's not possible to do that. Okay, now you can't printf a whole array and you can't scanf a whole array. It just doesn't, you can't do it, because if you try and say, okay, could you please printf, what %d in here, if you do that, and then you say ice cream can sum, it doesn't make sense that you can do that, right? Because this is just one D, and this is a whole array of things. There might be a whole bunch of things in there. You can only print and scan one thing at a time, because 1% D means you're printing out one item basically. So you have to do it one by one by assigning the separate indexes to here. And usually we use an I for index to keep track of things. This is the only time that it's okay to use such, kind of like short I, J, whatever variables. And then you'll I++. So you can see already the loops are going to become very useful to you because you're going to loop through an array and you're going to keep assigning things to it. So let's do a simple demonstration of an array so that you can see what it's doing. And then we'll have a little break so that you can re-energize a little bit. Okay, where's my code? Here's my code. I'm going to get rid of this one. I think I've done numbers to do a really simple way to do it. A program to demonstrate a simple reading into an array and printing out the elements of the array. Let's say I'm tracking how many teas I drink each day over a period of a week. I mean, it's all really about my food consumption. I really love to eat. And also I don't drink coffee, so I do drink a lot of tea. Okay, let's do it. First up, create an array that can keep track of my tea consumption and initialize that array. Now I'm keeping track for a week, right? Over a period of a week. So how big do I need the array to be? How many elements does it need to store if I'm keeping track over a week? What do we reckon? 7. Excellent. Do the number of days in a week ever change? As I'm asking this, I'm hating myself for asking this question. It doesn't, right? So it's a really great place to have a hash define. So let's hash define max week. And I'm going to put it as 7 because it's never going to change. Okay, 6 is, you're right, 6 is going to be the maximum index that I can have, but there is 7 items. Okay, the 0 always, it sends you on a head spin sometimes because you always have to kind of do, okay, is it 0, is it 7, is it 6? So the 0 does, head spin you quite a bit. Okay, it's going to be an int because I can't, if you've seen me drink tea, I do drink half cups pretty often, but let's just go for the simplicity of it. We're going to do an int array. So that means each one of those elements in that array is going to be an int. And I'm going to call it tea drinks. And then, so I say the type I'm going to say the name of the array. And then inside square brackets, I'm going to put a 7. I want it to be of size 7, that means. So when the compiler gets to this point, what it will do is it will create an array. The square brackets is what says it's going to be an array. And so when we get to this point in our compiler, what it will do is it will create a block 3, 4, 5, 6, 7. It will create a block like this, ready to go, and each thing is going to be an int in it, and this is going to be called tea drinks. Okay, so this array is going to be created when we do that. Great. How much memory does this array need? Well, we kind of went through it. Each thing is an int. There is 7 ints, so it will be 7 times, 1 int, so 7 times 4. Great. And remember that these things have to be right next to each other. Okay, let's scan into the, actually, what I can do, I've said I'm going to initialize it. Oh, all right. So this is me just declaring it. There's nothing in the boxes yet. I've just declared it. I can initialize it as well. If I want to initialize it myself, I'll do an equals and a curly brackets, and then just list numbers, and it will assign them, assign them through exactly as, exactly as I write them. So something like that, if I do that, what it will do is it will assign those numbers. It will have 3, 4, 56, 7, 8, 8, 2. So that will be me initializing that array. But because we're having fun, why don't we just read into this array? Okay, why don't we, so that's a way to initialize it straight away and give it some values. Yeah, I was trying to write 5 and 6 and I wrote 56, so I went with it. That's a lot of T's. You wouldn't see me that day. I'd just be in the bathroom the whole day. Okay, let's scan into it instead. So I'm going to get rid of this. Actually, you know what I'll do? I'll keep this line in here to remind you how to do it. And then what I'll do is I'll just declare it. Int T drinks and square brackets, how big I want it to be. How are we going for time? 11 o'clock. I reckon I can do it. 5 minutes and then we'll have a break. We can also scan into the array one element at a time. Okay, one element at a time. What do we think we need to do if we're doing things one element at a time? And each time I need to go to a different part of the array. 0, 1, 2, 3. I need to access a different index each time. So I know if I'm scanning in, I'll scan something in. Yeah, absolutely. So I'm going to have a while loop or a for loop, whatever you like. Okay, so to create my while loop, I'm going to need an index. So I'm going to have an int I. I'm going to start it at 0 because that's really where I start counting. And if you want, I'll do it as a while and then I can do it as a for as well if you want. Okay, what will be my condition for the while loop? What do we think? What do we think will be my condition for the, how long will I keep scanning? How long do you reckon I'll keep scanning? Yep, until I is less than 7. Well done. But I actually hash defined it and then I didn't use it. So instead here I can use my hash define. And here as well I can use a hash define. Okay, so if I is less than max week, then what I want to do is I want to scan into the element of the array. So I'm going to do a scan F, I'm going to do a %D, and then I'm going to put my ampersand, and I'm going to scan into this T drinks, square bracket I. So what I've said is if I is equal to 0, I'm going to scan into whatever the index is. So if it's 0, that means the first thing I do is scan into here, into the 0th element. Then I'll go into the first one, into the second, and so on and so forth. Okay, if I'm doing a while loop, I have to remember to increment myself. And so I'll do an I++. Okay? Okay, great. I should probably also ask the user so that we don't get confused. How many teas did you drink on day, oh my gosh, %D. And then what I'll do is I'll have an I here. And I'm going to do I+1 in there, okay? Because 0th day is very hard to think about. Or maybe I just won't confuse the matters. I'll just do I and we can just see how it works. Okay, so that's us scanning in, but now how do we print it out to terminal? Well, in exactly the same way, really. Okay, I'm going to do this one with a for loop. What do we think? Just so that you can see, you can use either one, doesn't matter. How are we feeling? For loop or while loop? How should we loop? Loop-de-loop, I hate the lag on YouTube. All right, for. Okay, let's do a for. So we can see how it's done, okay? I'm really doing the same thing as I'm doing above, but I'm going to use a for loop. So it's not, max week does have a value. It's a hash define. It's a value of 7. It's up here, define max week as 7. Okay, let's do it as a for loop. Okay, so remembering that the for is going to have 4, and I'm going to have my I is equal to 0. That's because I already have an int I over here, and I've just reset it back to 0. My condition is I is less than max week, because that's my I is less than 7. And then what I do afterwards is I increment my I. Okay, that's my for loop. And then all I want to do is print out the number of teas you drank on day %D is %D. So my first %D is the day number, and the second %D, I want to be able to access my array elements. So I'm going to call the array T drinks, and I'm going to ask it to access the ith index. So let's do save, and let's try compiling it, and then I'll go through it with pen and paper. Okay, a whole bunch of semicolons that I've lost somehow. Oh, and again, not in a semicolon kind of mood today. Let's try that again. Beautiful. And let's run it. Okay, how many teas did you drink on day 0? I drank 4 teas. I drank 4 teas, 4, 4, 4, 4, 4. Great. So I've drank 4 teas every day, and then it says you drank 4 on day 0, 4 on day 1, 4, blah, 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 blah. Okay, so it's doing it nicely. I really should have had a space here as well. Okay, so what that looked like and what this loop, I'm going to go through this loop quickly, and then we're going to have a break. Okay, so we've got ourselves a beautiful array, and what is going to happen is now, okay, line 18, we've got the array. It created this structure over here. Now we go in here, and we've also got a variable I. I'm going to put the variable I over here. Now we've got I is equal to 0. Excellent. I'm going to put a 0 here. I'm now on line 22. Is 0 less than 7? Yes, it is. I'm going to print out this structure here. And I'm going to scan F, whatever the input is, into T drinks I. If I is equal to 0, that means I'm scanning into T drinks at index 0. So the first one is going to go in here. Then I'm going to increase my I. I is going to become 1. And I'm going to repeat the procedure. So now I'm going to go into 1. And now I'm going to go into this one, part of the array. And then I'll increase the I to 2, and I'll keep going back, and I'll do, is 2 less than 7? Great. Is 2 less than 7? Yes, it is. So I'm going to go again. I'm going to go into the second element of the array, and so on and so forth. Okay, so that's how that one worked. And let's say I entered 4 for everything. Okay, similarly, that means now there's 4s over here, just like I entered on the screen. If I do this for loop, my first I is equal to 0 again. So whatever I had finished with a 6 before, now it's 0 again. I'm going to check, is 0 less than 7? Yes, it is. I'm going to go inside this statement and say, okay, print it out and access it at index 0, because I is equal to 0. So I'm going to access this one, print out the 4. At the conclusion of this loop, I'm going to do this I++, so that means I'm going to increase it. So now I'm going to be accessing the first element. So now I'm going to move on to here, and that means I'm going to print out a 4. I'm going to increase it again, and then I'm going to go up to here, and so on and so forth until I get through it all. Okay, I think now is a good time for a short little break. So how about we do a short little break, and then we will reconvene after that. Okay, hang on. Where am I? And then maybe, Tom, could you please pop a poll down about how we're feeling about accessing things from an array? I can finish my sentence. Yeah, scanning in and printing out. Thank you. Okay, let's have a little break. 5 minutes max. Yeah. Alrighty. Let's Kahoot. Wake up, everyone. It's time to answer quiz questions. Oh, so many sad faces. Why? Team living front. Because you're Tom killing back.
That's pretty funny.
That's a good one. All right. A race for life. Yeah. I love the names. All right, we'll wait one more minute. I don't know why I feel the need to bob to this music. I haven't stopped bopping for like 5 minutes. All right, let's start. Let's get this party started. Are we ready? Are we steady? See if Tom gets them all right. The pressure is on. Here we go. Okay, not bad. I think maybe I need to do more time for some of these ones with longer chunks of code. Okay, let's try the next one. Whoa. Okay, good one. I like this. It's giving me ideas for examples for next week. Next one. Okay, let's try this one. This is probably against every OHS, what I'm doing right now, standing on a chair. Okay, beautiful. Okay, good, very good. Let's try more. How many more? I think there's 2 more left. not bad. Last one, I think. Last one. Yeah. Very good. Okay. All right. Okay. We are going to go over the answers. Should we go over them now? Or let's go over them next week as a recap. Yeah, we'll go over them next week as a recap. Let's see who's on the podium today. Oh, Liv. Is it? Kahoot. Great name. Who's number one today? Well done. Questions and answers not in sync. What do you mean? Oh, there's a lag. Oh, there's a 2-second delay. That's why. Yeah, there's a 2-second delay. We can't really make it go any. Yeah, I'm going to extend the time next week for the Kahoots. Make it 30 seconds so that it doesn't play into it as much. Nice. Well done, everyone. Hope that means everyone's awake. It really hates me once it stops. It's hung. Okay, I'll have to go over it next week. Now it's literally playing the music after I close the window. Oh yeah, now it's stopped. There we go. I create some sort of problems before I even, yeah. Okay, fantastic. So how are we feeling about arrays? Where was that poll? Show me the poll. Okay, not bad. People are getting these arrays. Let's do one more example of arrays and then we're going to talk about strings a little bit. Okay, let me save this as well so that you have got access to the full thing. Okay, this program puts together all the things so far we've learned about arrays, scanning into, printing and manipulating a 1D array. So we haven't manipulated it yet, so now is the time to manipulate. Okay, let's have a look. I meet my friend for ice cream every day for a week. I don't drink coffee, as I've said. We want to be able to track how many ice creams in total we all consumed in a week, and also who ate the most ice cream in that week if we've got time. Or something for you guys to try out as well after the lecture. Okay, so let's see, what do I need to do? What are we talking? How should we solve it? What do we need? What do we need? What can we do? There's that delay. What should I do? What will I need? I mean, similarly to the last one, I will need a few things. Oh, the delay is very bad. All right, I'm going to have to start answering my own questions so I'll just stop wasting time, which is a shame. Oh, you know what? It's, yeah, how awkward. It's because I forgot to switch my camera back on. And I was standing on a chair before, which is not really okay. But now I've come off the chair and I'm just normally standing on the floor, so I can switch the camera back on. Okay, why would anyone stand on a chair? I don't know. Don't ask. No one asked. I don't know why I'm telling you this. Okay, here we go. So what are things that we have to do to answer this question? What are some things that we can do to start coding? Let's write a plan. Let's write a little plan. What are some things that we would like to do? Yep, we want an array. Now I've got me and my friend. So how many arrays do I need to create? So I need an array for me, and I need an array for my friend. Excellent, I like it. I like it. So I need 2 arrays, one for me, one for my friend. Fantastic. Now I want to be able to track how many ice creams in total we all consumed in a week. So really what I need to do first is I need to be able to ask how many ice creams you consumed on a day-to-day basis. So ask the user for how many ice creams me and my friend had on each day of the week. And that's going to be our printf. And then I'm going to take in the numbers. So that's going to be my scanf. And then I need to calculate the total. So I need to add all the numbers in each of the arrays together. So I'm going to need to total. And I'm going to need to give it some arrays in there. And we're going to talk about how we do that. Excellent. And then I'm going to print out the total. And that's going to be a printf statement. Okay, so let's see what we can do here. Let's see if we can actually put it together. Okay, we need 2 arrays. They're both storing, so I need an array for me. Array is storing numbers. So int, and the same for this one here as well. The array is storing numbers. Okay, so I need 2 arrays. They're both of type int. So int, first one is my ice cream. And I want it to hold for a week, which means that the size of the array is going to be size 7. So I've declared that I want one of size 7. And I want another int, and this one is my friend ice cream. And again, same size of the array. Excellent. We now have 2 arrays, and that means now we're ready to ask the user how many ice creams me and my friend had on each day of the week. Okay, what do you want me to use? How should I do this? Should I scan in? Should I scan in element by element, or should it just scan in together? What am I doing? Talk me through it. What do we think? What do we reckon? Where do we want to go with this? Yep, element by element. Excellent. So remember, with an array, you cannot scan in the whole thing. You cannot print out the whole thing just with one statement. You have to do it element by element because there's separate elements sitting inside this array, even though they're of the same type. Okay, how many ice creams? I'm going to do it so that we can go faster. Did you and your friend have on day? Okay, now I'm going to be scanning through these arrays. So really I want to have an index to keep. I'm going to set the index to I is equal to 0. Good question. Do we do 2 separate loops, one for you and one for friend? It depends how I'm asking for things and whether I'm putting it in at the same time. If I'm putting it in, scanning it in at the same time, then I can have one loop and just go in that loop for both people. So I'm going to use for a while. Oh, I can't decide. This is the hard part. This is why I didn't used to teach both, so that I didn't have to make this decision. I prefer a for, but I think other people want to see a while. I'm going to do a while loop. Okay, and yes, we will also need a total variable at some stage. So I'm going to make that. Good idea. Oh, people are saying for. Oh, and while. My gosh, I'm going to do one while, one for, just so that you can see both happening. Okay, if I'm doing a while loop, the first thing I'm going to do is the index, I've got the int I is equal to 0 here. So that's my loop control variable. My condition is going to be, I'm going to keep scanning whilst I is less than my week. So what I'll do is, I'll go inside here. I'm going to ask my question, And I'm going to fill it in with the I so that I know which day I'm on. And then if I ask this question, then I want to scan in two things. Yeah. So scan in %D and %D. And I'm going to scan it into two things. The first array is my array. So I'm going to scan it into my ice cream at index I. And note that the index is going to be the same for both the friend and the other ice cream. So that's going to work for us to do it both at the same time within one loop. So I've scanned that in, fantastic. Now I just have to remember to increment my loop control variable, and that means now I've been able to scan everything in. Okay, great. I've scanned in some numbers now. So I've done 2, 3, I've done 4. Now I need to add all the numbers in each of the arrays together. So there's really two ways to do it. One way is to just add in that loop as they happen, right? Another way is just do it separately outside that loop. The reason I'm going to do it separately outside that loop is to show you another loop, but it doesn't mean, you know, you can do it a lot more efficiently by just doing it all in one loop and just adding them as they occur. I'm going to do this as a for loop, okay? So let's say I'm going to have a for, and then I'm going to have I is equal to 0 until I is less than, yes, I can do both, and I plus plus. So I've got my initialization, so I've initialized the variable that I'm controlling it with. I've given the expression how, you know, what will I keep going until, and then what to do at the end of each one, which is incremented by 1. Okay, so now I'm going to do in here, and I'm going to say, okay, that means I want you to do total is equal to total plus, and I want to add whatever's inside my ice cream at I, and I want to add whatever's in my friend's ice cream at index I. Does that make sense? The way I can do it inside here, if I wanted to do it in one go, once I scan it in, I can just update the total plus, and then I can do the same thing in here. My ice cream at index I plus my friend ice cream at index I. Because the index is still going to be the same, and now there's going to be, oh, look, I made a mistake. No one saw it. And that will, you know, that will just do it. That means I don't need another loop as well. So you can do it either way. One is a bit more efficient than another. Okay, great. So now I have a total as well in here. This is just a little bit too easy almost, isn't it? So now all I have to do is print out the total, and let's see if it works. If I can spell. Nope. And it's going to be my total. Okay, should we try if it works? Okay, compiled first time, always fun when it does that. Okay, how many Acid Junior friend haven't? Oh, I hate it when I forget to put I'm sorry, I'm just going to quit out of it because I really hate it when there's no space. It really annoys me. Okay, thanks everyone. Okay, let's do this again. Okay, here we go. On day 0, we had 5 and 6. We had 1 and 2. We had 2 and 3. We had 2 and 3 again. We had 3 and 4. We had 5 and 6. I'm not adding these together, so I don't know if the answer is going to be correct. Total ice creams is 57. I should have just done ones. Okay, let me do ones. 1, 1, 1, 1, 1, 1, 1, 1. Otherwise, Tom was grabbing his calculator. 1, 1, 1, 1. Okay, and the total number of ice creams is 14, which is correct. 2 and 2 times 7 is 14. Excellent. So, not too bad, is it? How are we feeling? Great? Feeling fantastic? Feeling the best? Loving arrays so far? Yeah. So you can manipulate them. You can do anything by just accessing whichever index it is that you need. How are we feeling about our ice cream? And don't worry, we're going to keep practicing things. Okay, so it's not, you know. And if you wanted to rewrite this while loop as a for loop, all you could do is you could just have here, instead of that while, you could have a for, and then you wouldn't even need, you know, I is equal to 0, I is less than max week, and I plus plus. And that way you could do it as a for loop in here, and that means you wouldn't need line 37 either. Oh, I didn't mean to do that. Okay, fantastic, very good. Great. I think you're saying, okay, every while loop could be replaced with a for loop. Not quite. So I think I breezed through it, but there is, look, yeah, okay, you can really do almost everything with a for loop or a while loop, and when you're at an industry, you'll see people have a certain preference for each one of them, but a for loop is usually used when you know how many times you're going to loop, and a while loop is better when you don't know how many times you're going to loop. So that's really the difference. So something like an array, because we have where we start and we have where we end, it kind of lends itself nicely to a for loop. It's easy to do. But a while loop is better if you don't know how many times you're going to go around the loop. Yeah, Tom, there is. Yeah, there is a random function. Yeah. You know, all those random functions, they're not actually random. I'll leave that as a piece of trivia. Okay. Do I have to initialize the variable inside the parentheses of the for loop? I is equal to 0. Yes. Yeah, you can. Yeah. You should initialize it. Good practice. Yeah, like technically you can have just, you can have an infinite loop in a for loop just by not putting anything in at all, but no, you will never get marked down for which loop you use. A loop is a loop. And as you get better at coding as well, and as you see different types of problems, what will happen is you'll get better at kind of, well, you'll probably get a preference, but you'll get better at picking what you should be using and what's better in which case. But at this point in time, we really want you to focus on being able to solve the problem. So we're not gonna, yeah. Oh, I did want to say, okay, assignment is due on the Friday at 8 p.m. But the lab, because Monday's a public holiday, there's no class, there's no lecture, the lab will become due on a Tuesday so that you can have a bit of time, I don't know, to sleep or, actually see your friends and enjoy your long weekend. So the lab will actually be due on Tuesday at 8 p.m. and I will put an announcement about it so that, you can have some enjoyment from the long weekend. But this is the best term, really. Term 3, you can feel December just around the corner. Summer is in the air. Look at the beautiful blue skies. It's amazing. I love term 3. You do. You need the 3 or 4 days, and then assignment 1 should hopefully be on Wednesday to allow you time to, Wednesday in the lecture, we'll start talking about what it will look like. And then, the following week, in week 5, we're going to go through a program that's going to help you do your assignment as well, the first few stages. So we're going to do like a lecture program thing, and it's going to be a whole big exercise that we're going to solve in the lecture, and it's going to really help you towards assignment 1. Okay, let's talk about strings, because strings are arrays in C, because C is like that. Okay, so we mark the labs the week that they're due on the Friday of the week that they're due. So your lab's due on a Monday and we'll mark it on that Friday of that same week. Okay, strings. What are strings? Strings are, not string theory. I don't know why I decided to. I remember when I first learned about string theory and it just blew my mind. Anyway, okay, so strings are a collection of characters that are joined together. It is an array of characters, okay? That's all strings are in C. They are an array of chars, but there is one very special thing about strings in C, okay? They are an array of char, but the final element of that array is a symbol called a null terminating character, and I didn't put what it looks like. It literally looks like this, /0. And this is called a null terminating character. And that's how we know that it's a string. If it has that null terminating character, then we know it's a string. If it's just an array of char without that, then it is just an array of char. So you can have an array of char that's not a string, but you can't have a string that's not an array of char. Wow, that was, get your head around that statement. That null terminating character is always located at the end of the array, and you always have to have an array that's able to accommodate it if you've got a string, okay? It's not displayed as part of a string because that would be madness and super confusing. It's already confusing enough that it's a part of the array, but it's not displayed. It's basically a placeholder that lets us know that this array of char is actually a string. And it is a useful thing if you think about it. If I've got a string and I want to loop through that array, this is really useful for me to know when that array finishes. So for that int array, I went until, less than 7 because I knew that a week has 7 days in it. So I knew that I have 7 items in that array. But in a string, this is how I know the string has come to an end, is I've got this null terminating character. So for example, and this is what it looks like, okay, my goodness, I don't know what is going on. Nothing's going on, just me on a morning. So this is what it looks like inside the array. Okay, let's say, and this is how we, there's 2 ways to do it, but you'd have to be mad to do it this second way because that's a lot more effort. So I've got an array of char, okay, because characters make up a string. So I've got an array of char. I might not have a size in here because I'm initializing it straight away, and this will automatically create the right size for me. So if I create an array word and I initialize it to say hello, this is my array here. It's called word. Each thing is a char, and what it will do is it will place the letters of hello in here. So HELLO. And what it will do then, because I've indicated it's a string, by using the double quotation marks which say it's a string, it will also create an extra element where it will place a null terminating character. So you can also define it or initialize it by doing it character by character, and then you have to then include the null terminator yourself. You have to think about it, but I mean, don't do that. That's quite annoying to do. You can if you want. I'm not stopping you, but not very efficient. This is the way that you really want to be doing your strings, because then it will do the null terminating character for you already. Okay, so double quotation marks and whatever the word is that you want to place in there. Okay, how do we read strings off the terminal? We have done scanf, haven't we? And so far we've read every single thing with scanf, haven't we? We have. I don't know why I'm asking you. I can answer it. Now, scanf does have a %s for string, but it is a bit of a dangerous thing to use, okay? So we don't want you to use %s. And a scanf with it, okay? It will work, but don't do it. But it will work, but don't do it, okay? the reason for when you do a scanf%s is that you don't indicate any size for this array, and that can create a lot of unwanted consequences. So instead we use a function that's available to us, okay? We want a function. We have a function. Amazing. We don't have to write it. All we do is we use something called fgets, okay? And this fgets is the way that we read a string from terminal. So we'll take an fgets, and fgets has 3 parameters in it. The first thing is the array name that you're reading into. That's where you're going to store whatever it is you're reading, the string. The second thing is you are saying the size of that array. What is the max size of that array? Okay. And then the last thing is where on earth it's coming from. Okay. For you, you only have to remember one thing. It will never ever change for you in 1511. It will change further on. Look at how blurry I am. And it's always going to be stdin. Okay, what this means is standard input. It means that you're taking it from terminal. There are other things that you can get stuff from, like files and other things altogether, which is why you specify where it's coming from. In 1511 for you, it will always be stdin. Oh, there's a spelling mistake here. That should be an stdin. So for example, if I have an array of chars, so I declare an array, the array is called array, and it's got maximum length, which is specified in a hash defined somewhere. To read into that array from terminal, I'll use my fgets. I say I'm going to read into the array because that's the name of the array. I'll say what the maximum length of the array is by specifying max length. And then I will just specify the third key term, which is standard input. Okay, good. All right, good. Are we ready to keep? I'll just go one more concept and then I'll put it in. You know what? No, actually, no, I'm not going to do the next thing. Just hold on. Wait for it. I'm going to go back. We're not going to do this yet. I'm just going to show you how it works because otherwise it's a lot of information to sit on. Let's see how it works. I'll go to strings and here I have the beginning of this file. Okay, so the first thing we'll do is we'll go in here into the main and I'm going to declare an array. So I'm going to say char array. And the maximum size, I'm going to use the maximum length, which I've given here as 15 in a hash define. So what this has done, as soon as it gets to line 14, it creates an array for me to put stuff into. So it's going to create this array called array. And it's going to be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They're all the same size, contrary to what it looks like. And each one of them is a char. So I've got this array, and remember indexing starts at 0. And I haven't yet really said it's a string. So what's going to happen here? So I need to be aware that really, if I'm going to make it a string, this last thing is always going to have the null terminating character in it if I make it a string. Okay, so how can we put a word in? Let's try it. So I'm going to say a printf here, and I'm going to say enter a word. And then I'm going to take that word out. I'm going to use the fgets function, and inside there's going to be 3 things. It's going to be the name of the array that I'm going to read it into. It's going to be the maximum length of my array. And then it's going to be always the keyword standard input. Excellent. So now what happens is whatever was entered in terminal is going to go inside this array. And let's print it out, and then I'll show you something that I'll show you a little funny thing, quirky thing. So print out is a %s. And I'm going to print out that array. Okay, let's see if we can compile it. Okay, compiling. And I've also just realized that I've just told you can't ever do this, but I'm doing it. I'm doing a %s and then I'm calling the array. The only time you can do it is if it's a string, okay? Because it knows where a string ends, okay? Okay, and let's run it. Okay, great. Enter a word. I'm going to pop in hello, and it's going to bring it back to me. Hello, okay? Fantastic. How do you think I can break it a little bit? Or a lot? How can I break it? How can I break it? Don't know why I'm doing everything in song. Yes! Amazing! Type something long. Absolutely. Type more than 14 characters. So let's do it. I'm going to do 14 characters. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So will 14 be able to do it? Yep, 14's okay because I still have a space for the 15th null terminating character. What if I now do $15 characters? Look at this, look what it does. It goes and cuts the last character off because I need to have this lovely null terminating character. Now, oh, well, there you go. Daniel's already answered the next thing as well, which I was going to say. If you noted here, after my hello is a random new line. And that's because I pressed a new line over here after my hello. And it gave me that new line as a character as well, because that is a character, as we remember. Here it did not, because I had 14 characters. So when I pressed enter, that was the 15th, and it got cut off. And here I had an extra letter and an enter, so it cut off all of that as well, right? So it's going to take that enter as well, because spaces are still characters on the ASCII table, and so are new lines. Okay, so it does, just always kind of, you really got to try things out as well to see what on earth it's doing and why it's doing it. Now, I haven't gone through. Okay, so how can I keep reading a string until, how can I make a loop, okay? And the way with the string to make, if I want to keep reading, if I want to have, how do I stop it from reading or not reading? The condition is, and it's a keyword as well, it's this null keyword over here. What this means is that you can press Control D to stop reading. And so, good questions, okay? I am going to answer those questions, those a little bit food for thought, but I am going to answer them next week when we go through it again in more detail, okay? Don't worry, we're not just gonna, this is not the end of it. We're gonna keep going with strings a little bit. But I just wanted to do this introduction to strings. It's really just an array of char with a null terminating character. So I've introduced you to a function, fgets, and what I've done is I'm now telling you, you can keep reading things in. And as we've seen already, we've seen these conditions. We've seen that when length -1 characters are read, it stops reading and it, outputs it. New line character is read. We've seen that as well. And the other way it stops reading is that there is an end of the file, whichever comes first. So one of the things that we do is we check that it's not equals to null, and it lets us have a loop of taking in, different things that we want. There are, and I'll do a program next week that will demonstrate it. So don't worry about this for now. This is just, don't worry. I think maybe this was too much. I'm going to take this slide back. Okay, don't look at this slide for now. Okay, let me go back here. Okay, I can swallow up the enter, okay, if I want to. Someone has said, do we need to stop it from printing the enter? We might need to. And we can swallow the enter, which I will show you in maybe not enough time today, but I will show you how to do it next week. But you literally just take the enter and throw it out. You can move the null terminator, you know, somewhere along the lines to cut out the enter, or you can do a few other things. So one way to do it, okay, I'm just going to show you now because I'm already talking about it. Okay, one way that you can do it is you can loop through the array and look for the enter. And instead of that enter, put a new line, put a null terminator in. So we know that we can loop through. So let's say we have an int I is equal to 0. And I can do a while loop that searches for that enter. So I'm going to loop through my array. So I'm going to say whilst, what's my array called? Array. So whilst array at I is not equal to a new line, I'm going to keep going. And that means when I go inside this while loop, it is equal to a new line. And then I can just say, okay, that means I want array I to actually equal to a null terminating character. So it's like instead of the new line, I'm going to replace it by a null terminator. And you might not ever need to do this, okay? But this is one way to do it. There are other ways to do it as well. Okay, let me just erase because it's very messy here. So what I've done here is, let's say we're going to enter in hello over here with the enter. We've created this char array. Let's pretend that this is 8, okay, because I don't want to, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4, 5, 6, 7. Great, this is my array that I've created. Someone enters in hello, so it will go in here, hello. It will put in the new line, and it will put in my null terminating character, okay? So it's got my null terminating character in here. So all I do when I do this while loop over here, I set my index to 0, and I check each element of this array. So I go in here, and I say, is this equal to new line? No. Continue. Is this equal to new line? No. Continue. Is this equal to new line? No. Continue. Is this equal to new line? And until I get to the new line. And then what I do is I just move my null terminator into there. And that means I've cut it out of the array. Well, that was fun. We're almost at the end, really. Okay. I'm going to stop there because otherwise too much. Too much? Okay, maybe do one last poll. How are we feeling? Okay, if you have any feedback from today, let me know. Anything that you want to cover as well, you know, next week if something is not clear, anything that you want to go over again, any particular program you want to do, just let me know on the feedback as well. Yeah, it's a lot. Sometimes it's a lot. It's going to be a lot. Did I make a mistake? I might have made a mistake. Let me go back. Oh my gosh. This whiteboard hates me. Where did I do it? Yes, it should be. Yes. I should be searching for it to, yeah. Well done. It should be. Yes, that's a great question as well. Printf string will ignore, it will use that null terminator as, it will say that's the end for me. So it will ignore things after the null terminator. No, don't worry. We've still got time. I've got another week to convert you maybe. There is, you know, I don't know, sometimes it feels like it's all too much, but then you start playing with them and you kind of see it all come together, and it is quite magical what it can do. But I always find the best thing to do is just write it down with a pen and paper as well. I am turning each array into it. Yes, this is what happens when I just change. Yeah. I should really check. Yes, because I'm not doing correct check. That's why. Okay. Int I is equal to 0 whilst array I is not equal to new line. This should be outside of the while. I'm just going to increase the I++. There we go. So when I come out of this while loop, it's going to be equal to new line, and that's when it should be equal to, and then I can print it. This will now work. Yeah, there we go. Look at that, good problem solving. Well done, good pickups. There we go, beautiful. Well done, everyone. I hope you have a good rest of the week. And I hope you have a wonderful long weekend. Good luck with your assignment 0. And I hope that, I hope you can finish it all and not feel stressed about it. And then we can, then we will continue with assignment 1, which will kind of also get you a little bit of stress. So good luck, have a good rest of the week, and I'll look forward to seeing you next week. Have a good public holiday. I'll see you on Wednesday next week. Bye everyone, have a good one.